Our goal here is to graph m of x, which is 2 times the quantity x minus 1 squared plus 3. So to do so, we're not going to make a bunch of, we're not going to make a t-chart and plug in a bunch of x values, anything like that to get y values coming out. Instead, what we're going to do is start with a pretty basic graph, the x squared graph that I've tried to draw up here already, and then move it around utilizing transformations. So I started with the x squared graph because our exponent here is the 2. It's kind of telling us that x squared is our basic starting graph. Next, what I'm going to do is apply the transformation, this 2, out in front. Now that 2 is being multiplied by the entire function, so our next graph is going to be y equals 2 times x squared. All right, because that's a 2, it's bigger than 1, we refer to that as being a vertical stretch. And what that does is it takes all of our y values that are right now represented with x squared, so like this ordered pair, which is 1, 1 on this graph, we're going to take that and multiply it by 2. But it's represented as the y values over here, so it's going to be twice as far away from the x-axis on our new graph. Same thing's going to happen to, sometimes we pick out a few key points, like 0, 0 is going to stay where it is. Negative 1, 1 was on the original graph, so negative 1, 2 will be on our new graph. But basically, it's going to make our graph look taller and skinnier. So I'm going to keep the lowest point still at the origin, but like I said, that next point is going to go up to like 1, 2 and negative 1, 2. Basically, our graph is going to look taller and skinnier than the original. Not being super accurate with this, but as you can see, mine definitely looks taller and skinnier. I'm not going to track around those individual points from here on out. Mostly I'm going to focus on that lowest value, where it is right now is at the origin, and move it around as we go. The other two transformations we can do in either order, but let's keep building as we move over here. So we have the 2. I'm going to apply the one that's attached directly to x next. So I'm going to pick up my graph and I'm going to move it based on that transformation. Now that minus 1, like I said, attached directly to x, it's inside the parentheses with x. So what that's going to be is a horizontal shift of some sort. In this case, it's going to kind of work the opposite direction you think it should. This is going to move to the right 1 unit. So as I work on this, I'm going to move to the right 1 unit, but basically I'm going to pick up this exact same graph. So I'm going to copy it, put it over here, pick it up and move it to the right 1 unit. Looks like mine brought along all the rest of it as well with the 2's. Let's see if I can erase those in the middle. Okay, let's go ahead and copy this because I'm going to move it one more time. All right, the last transformation we still need to take care of is that plus 3. So our final graph that's going to be displayed here at the bottom, y or m of x, is going to be 2 times x minus 1 quantity squared plus 3. Well, that 3 at the end is attached to the entire function, so it is going to be a vertical movement, and in our case, it's going to move everything up 3 units. So I've already moved the graph to the right one. Now we go up 1, 2, 3 units, and we're going to set it back down. So as we take a look at this, we were right here. Now we're going to pick it up and move it up 1, 2, 3 units, set it back down, and that is our finished graph, what this should look like, drawn right through the middle of our function. All right, but that's basically how we can utilize transformations. It's a really worthwhile exercise and thought process that it can really help us get very good graphs without doing a whole lot of work. This is way easier in the long run after you pick it up than making t-charts and plugging in a bunch of x values to make points on the graph and then plotting those and connecting the dots. So I hope this helps out. Good luck.